Hi everyone, welcome to the third video for topic 4.2, loans, investment and annuities. So we are still under the subtopic of compound interest loans and investments. So there are two things that we are going to do under this lesson. So the first one is that we are going to revisit the question that we solved in lesson 1 that regarding to the part for compound interest. But then in this case, we are going to use our calculator, which is the TI Inspire, to help us to solve all the questions that involve compound interest. Then after that, the second thing that we are going to do is we are going to look at depreciation. Okay, so this will be something that is quite straightforward and quite easy lah. You just need to differentiate the different method. Then after that, understand how to calculate them. Then basically that's the thing. Okay, so two things. The first one, compound interest with financial solver. The second one is depreciation. All right, so let's start with our first part. Alright, so in our TI Inspire calculator, there is an inbuilt application which is called as Financial Solver that will be able to help us to solve the question regarding compound interest. So remember that for all the simple interest, you can't use this calculator. You can't use the application for Financial Solver to do that because it is set to use it for compound interest problems only. Alright, so I've put in like the tutorial, the guideline here, but I'm going to go through with you again with calculator, with the real calculator here, so you can try to follow step by steps. Alright, so these are some simple notes for you. If let's say you forget in the future, then you can try to refer to the notes here. Okay, so the first thing, how to on it with our calculator. Alright, I hope that you have grabbed your calculator with you. So let's open another new document. So after you open a new document, then add calculator. Alright, so add calculator. So after we add calculator, then I can look at the notes here. Press menu 8.1. Or if you are using your cursor, then it will be menu, then finance, and after that continue with finance solver. So if you are using your pad in your handheld, then you can just do menu 8.1. Alright, so you'll be able to see this special table here. So this is a special calculator that meant for financial mathematics. So how are we going to use that? So you can see these are some further explanation about all the term here, but you doesn't really need to memorize it because everything will be written at the bottom of your calculator as well. So you can see what is that meant by N is the number of periods. So I, interest rate, and it must be in percentage. PV, present value. PMT, payment. FV, future value. PPY, payment per year. So that's why PPY. Then CPY is compounding period per year or compounding per year lah. So CPY. And the last one we have payment at. Alright, so now let's try to see how are we going to use the all these things when we try to compare it with our formula. Okay, so the first one, the N here meaning what is the time or how many payment that you do or how many compounding periods that you do. Okay, how many compounding occurs during your investment period lah basically. Okay, so remember that the big N here is not the same N that you are writing in the formula. So the NT here is actually the NT. Okay, it's the value here. So which means that if let's say we are talking about if it's an investment that you compounding that is compounded annually, then you are doing for 3 years, then it will be 3 times compounding. So that's why your big N will be 3. So if let's say you are doing 3 years but compounding 4 times per year, then it will be 3 times 4, which is 12 times compounding. So that's the idea for the big N here. Alright, then after that, I is the interest rate lah, so which means it's the small r in our formula. So PV, present value. So this is the value that you are starting off from. So which means it's your initial value, which is the principal in our formula. So no matter we are talking about investment or loans, then that will be the PV. So it's either the value that you invest or the value that you borrow from the bank. So that's something that's very special about this calculator is that it's a financial solver for like as if a customer kind of view. So if let's say you can try to imagine that when you are doing investing, right, you are actually putting the money in the bank. So that's why when we try to press in our TI Inspire, then we need to press negative. So which means that if let's say you deposited like $5,000 as your principal, then when we type in our calculator, we need to type negative 5,000. So that's the idea. So PMT, we are talking about payment. So in this case, we are not using anything about this first because we are talking about the situation where you put in a lump sum in the account, then after that you just let it grow, right? You are not adding any money after that. Okay, so but this thing will be changed when we talk about the deeper approach after you come back from your semester break. So in this case, all our payment will be zero. Then after that, FV is the future value, which means what is the total amount of money you have in your bank after you calculating the whole thing lah. So that's why in this case, the FV here will be your A. Okay, so normally when you put this as your negative, then your A will be positive because this is like the future value. You are getting back the money. So that's why the answer will be a positive. PPY is number of payments. So in this case, it will be referring to the payment here lah. So since we are not doing any payment, so you do not really need to change the PPY in the case as well. Then after that, for CPY is the number of times that in a year the interest is compounded. So which means if let's say it's compounded monthly, then it will be 12. If let's say it's compounded quarterly, then it will be 4. So which means this CPY is actually the N that we are having in our formula here. Alright, so I hope that you can get the idea. So these are some special notes for compound interest calculation. For all the PPY and CPY, normally it will be the same, and payment at normally we talk about the N. So yeah, for example, you know, when you put in a specific amount of money at one day, then after that, if let's say the interest is compounded annually, right, then which means that that's the money that you get at the end of the first year, that's the money that you get at the end of the second year. So that's the idea. So that's why later when we are solving, we are not going to change anything about the ending here. Okay, so that's the idea. Then you can try to go through the notes again. Okay, so now you can try to get your handout for your lesson 1, and we are going to go through some of the example for compound interest and see how we're going to use our calculator to do that. Alright, so let's look at the example. Alright, so we'll start off with question 7 in lesson 1. Okay, so again, let me repeat again, we cannot use this finance solver in simple interest situation, yeah? So that's why you can see that when we try to do this, we are using the compound interest question to to show you as an example. Okay, so in this case, then let's try to put in the value that we want. So this question, the question 1 is to find out the value of investment after 7 years. So which means you are finding the future value. Am I right? So MV is the thing that you are finding. Okay, so N is number of payment. So which means that how much compounding happened in the period of your investment. So this one is you can see that compounded annually. So which means 1 time per year. And you are finding the value of investment after 7 years. So which means the total compounding happened here is like 7 times. So 1 times 7. Then after that, the interest rate here, you are given 6.2. So remember, when we are using our formula, we try to change the percentage to decimal. But when you try to use finance solver, we keep it in decimal. We keep it as percentage because that's the instruction from the calculator. So PV is our principal. So he actually put in 35,000, right? So remember, in our calculator, you are giving the bank, you are putting the money in the bank. So that's why negative 35000. That again, cap. So payment, we are not doing any regular deposit, right? So that's why that's 0. So FV is the thing that we want to find. Then you realize that in this case, it's compounded annually. So that's why PPY and CPY will be 1. Then you doesn't really need to change it. So now you have all your information already. Then in your calculator, you can press enter. Then you will be able to get the value. So you'll realize that it will be the exactly same value that you get here. You see, the amount of money that you have in your account will be 53326.08. So you see, you get the exact same value here. And this value will be in positive because that's the value that you receive it after 7 years. Alright, so that's the case. So now let's look at example 8. Alright, Alright, so this question is the one that you're having the same principle, the same timeline that you put in, which is 4 years, then with the same nominal interest rate as well. Then after that, the compounding period is different. So that's why later we are going to change the PPY and also CPY as well. Okay, so when you are using this, you actually do not really need to delete the info. Okay, so this is the data that I put in the previous example. So when you want to key in another new situation, then you just tap. Okay, you just press tap, tap, tap. Then after that, you will just go back. Then you just straight away key in the new information. So for this case, let's start with the first one. So it's annually, and you put in 4 years. So 1 year, one time, and 4 years, so total 4 times. Alright, then after that, the I here interest rate is 6%, PV here negative 25000, payment 0 as well. So we are finding the FV. So in this case, we are doing annually, so that's why PPY and CPY is still 1. So we doesn't really need to change that. So just tap, then after that, enter. Then you'll be able to get the future value after 4 years. Then let's check. So you see, this value and this value is the same. So remember that the future value here is the total amount of money that you have in your account. It's not the interest here. So if let's say you want to calculate the interest, then which means that you should get the future value then minus off the present value that you are having. Okay, so now moving to the second one. So this one is quarterly. So which means what happened here is that our PPY and CPY, the number of compounding per year will become 4. So that's why 4, 4. Alright, then after that, moving onwards, this one we still set it as N. Then, yeah, if let's say now it's quarterly, so which means 1 year you have 4 times. So 4 years you have 16 times. So the N here will change to 16. Alright, then the I here is still the same, PV is still the same. Then after that, when you move on to FV, then you can press enter. Then you'll be able to see the value change. So when you try to check our answer in B, you realize that the answer is the same as well. So 31724.64. So that's why the calculation is correct. Okay, last but not least, this one for daily one. So again, daily one, what you can do here is the compounding occurs daily. So PPY and CPY will become 365. So again, tap, then normally they will try to change it for you. In the last, when we reaches the end of the lesson, we will talk about where you will have the cases for PPY and CPY different, but that is very rare, but definitely you need to know as well. Okay, then after that, and then the same thing here. So in this case, 1 year is 365 times, and you are doing it for 4 years. So if you realize that it's a bit hard for you to calculate, so if you don't want to calculate with your scientific calculator, then what you can try to do is you can straight away press it here. So 4 multiply 365. Okay, that works as well. Then you just tap, then the calculator will straight away calculate it for you. So the interest rate is still the same, PV is still the same. Then now we go back to FV, then enter. So you realize that this is the value that we get for our C. So 31780.60. So that is correct. Alright, so these are some ways for us to calculate the future value. And the next part, I'm going to show you some very cool thing about the calculator as well. So it doesn't help you to calculate your FV as well, but you can find other variable also. So let's move on to the next example. Alright, let's look at number 9. So this is the one that the question wants us to find out how many years will it take for the investment from 2,500 to grow until 3,700, right? Okay, so in this case, which means that we do not have our N, right? Because we do not know how many years. Okay, so that's the N that we are finding. Then after that, you can move on to the interest rate here. The interest rate here, you are given the 8% annual compound interest. So that's why 8. Okay, so present value, negative 2500. So payment 0 as well. FV, after the number of years, then you are going to get 3700, right? So the PPY and then CPY here with compounding every 6 months. So which means for per year, then it will be 2 times. So which means 2, 2. Okay, then the same thing at the end here, and we are finding the N. So you just press enter here, then you will be able to get your answer. Okay, so you realize that you get an answer like 9.995, then which means that you can kind of like round it to like 10. Okay, but 10 is not your answer. So remember, 10 is your NT. And 10 meaning like during the total amount, during the period of time, actually you compounded it for 10 times. But then for this one, you compounded 2 times per year. Am I right? So that's why how many years involved here is actually 5 years. So you should check that at the end. Yeah, it's 5 year. So 5 year because you compound 2 times each year, right? So that's why 2 times 5 and that give you 10 here. So 10 divided by 2 times per year, you get 5 year. Alright, so that's the idea. So you realize it's something that very cool. It's not calculated for your FV only. So you can actually eventually stop at any places. Then you just press enter here. Then the calculator will show you the answer. Okay, so let me do it again. So your info here, after you have put in everything, you just tap. Okay, then if let's say this is the answer that you want to find, then you just press enter, then the calculator will help you to calculate everything of this. Okay, so let's look at the last example. Alright, so this one about Patrick. So same thing. So in this question, the question wants us to find out the annual interest rate, right? So which means I is the thing that we are finding. Okay, so which means we can try to change our n here already. So in this case, you are finding your, okay, so in 6 year and it's compounded quarterly. So 1 year 4 times, so 6 year total 24 times. So interest rate here is the one that we want to find, right? Then just leave it. Then after that, tab. So your PV here, -14400. So payment also 0. Future value at the end, you are able to get 18,700. Okay. Then after that, in this case, it's compounded quarterly. So our PPY and CPY will be 4. So 4 times each year. Then after that, you just tap. Then until you go back to the I. Then after that, you just press enter. So at the end, you'll be able to get this answer. Then let's check the answer that we are having. So you see, that's correct. 4.44378. So 4378 here. Okay, and that's your answer. All right, so I hope that you can try to explore all these functions again, maybe by using the question that in your textbook that you have done it by using your formula. So okay, I need to make this very clear. Formula is still very important because in some cases, for example, I think the second last question in your example, you are not given what is your P and what is your final value. And in that case, right, the only choice that you can do is use your calculator. So that's why formula is still very important because in that case, you do not have a real value for your PV and your FV. So in that case, then you will need to use calculator and do manual solving. But then, yeah, remember how to use this finance solver, and we'll use this much more frequently when we move on to a harder approach in future. I mean, for now, for compound interest is still okay because we are not dealing with anything about payment yet. But in future, we are going to talk about regular repayment and regular deposit that you want to put into an investment. And in that case, the situation will be much more complicated. Then financial solver will become much more important at that time. Alright, so that's the part for calculator, and now we'll move on to the lesson about depreciation. Alright, so in financial context, we are not only using compound interest in investment or loans, but we also use it in depreciation. Okay, so let's look at what is that meant by depreciation first. So for a simple example, right, when we buy a car, the value of the car is going to decrease all the way over the years, right? So this decrease of the value of an asset is called as depreciation. So depreciation is defined as the decrease of the monetary value. So normally we talk about the money value lah. It's not like how much it worth like for your time and so on. So it's the monetary value. So the monetary value of an asset is going to decrease over the time due to the use or wear and tear. So this is called as depreciation. Okay, so there are some terminology that you need to know. So this word is called as the book value. So book value is the value of an asset recorded on a balance sheet. So which means that you have the value of the car in the first year, value of the car in the second year after depreciation, the third year and the fourth year and so on. So that's like the book value, the value of an asset. All right. So there are normally 3 ways that commonly used in financial context for us to calculate the depreciation. So actually you encountered these words before when you learn growth and decay in sequence, but that time is not so important because we are not dealing so much with money. But then for now, because the whole chapter here is about finance, right? So that's why we are going to repeat the thing again, revise again the thing over here. Okay, so the first thing that we know is called as the flat rate depreciation, or sometimes it also called as the straight line depreciation. Okay, so the idea for flat rate is very easy. So which means that the value of an asset is going to depreciate by a fixed amount each year. So which means if let's say today you spend 10,000 to buy a second-hand car, so maybe every year the value of the car is going to be decreasing by 1,000. So after the first year, then the car will become 9,000. After another year, then become 8,000. After another year, become 7,000. So this is called as flat rate depreciation. Alright, so the value of the car depreciated by a fixed amount. So normally this amount will be specific written in a fixed percentage lah. So which means in just now the case, if let's say you spend 10,000, then 4,000, then which means like it's decreasing by 10% each year. So that's the idea. So for this flat rate depreciation, right, you can imagine that it actually changes over the time. So this is like the time. Then after that, we have the book value for the asset. So which means what is going to happen is that if let's say this is the initial value of the car, right? Then after second year, it's going to decrease with a fixed amount. Then next year, decrease another fixed amount. Then the next year, decrease another fixed amount, and so on. So that's why you will see that you can get a linear graph, which is like a straight line graph. So that's why flat rate depreciation will be following an arithmetic sequence, because the amount that is fixed to depreciate each year is basically your common difference. Alright, so this is for the A1. Okay, so now let's look at the second one. So the second method of calculating depreciation is called as the reducing balance depreciation. Reducing balance. Okay, or sometimes this is also called as diminishing value depreciation. Okay, so in this part, the value of an asset is normally depreciated by a fixed percentage. Alright, so for A is fixed amount. For this one is fixed percentage of the value each year. So which means what happened is that for example, if let's say I'm talking about 10%, then which means that it's going to reduce 10% of the first year when I'm calculating for the second year. And when I calculated for the third year, it's going to decrease another 10% from second year. Then when you calculate for fourth year, then it's going to decrease another 10% from the third year. So which means that what is going to happen is that at the end, you are going to get a graph which is like an exponential one. Okay, so the book value here, the time. So no worry, later we are going to look at an example, then you'll understand it better. But basically the idea here is that the decrement will be getting lesser and lesser. So maybe it's like here, here, okay, next year, next year, next year. Alright, so by using a mathematical approach, you know that this thing will never reach zero logically lah. But we know that in reality, there will be a day that the book value of an asset will eventually become zero, right? Then when you are getting a number that's very close to zero, then we are trying to assume that as zero as well. Okay, so this is for reducing balance, so depreciated by a fixed percentage. Okay, then the last one we have, this is called as the unit cost. Okay, so unit cost depreciation is a little bit different with the two that we mentioned in front. So for these two, right, the book value changes according to time. So which means I don't care about whether you use the asset or not, as long as time pass by, then the value of the asset will be decreases. But for unit cost depreciation, we talk about usage. So which means that the value of an asset is depreciated by an amount related to the number of units produced by the asset during the year. Okay, so something about this very good example would be, for example, like a printer. So which means that this is the usage and this is the book value. So you can imagine that if let's say I started off with a value of I buy a printer with 500. Then after that, which means that if let's say I already printed out 1,000 copy, then the value of the printer is going to decrease like $50. After I print out another 1,000 copy, then it's going to decrease another $50. After I printed out another 1,000 copy, it's going to decrease another $50. So you can see that it will be like an AP, which give you a linear graph as well. But then the only difference between this one and the flat rate is that this is changing according to the time. So this one is changing according to the usage. So it's not about how long you have buy the asset, it's about how much you have used the asset. Alright, so that's the idea. So same thing in this case, we only have only one example. So I hope that by using this simple example, then you'll be able to differentiate the three different type of depreciation here. Alright, so let's look at the example. Alright, suppose a company purchase a machine worth 10,000 here. So first one, we are going to look at the depreciation by fleet rate. Then after that, second one, reducing balance. And the last one, we have unit cost. Okay, so let's start off with the first one. Okay, so which means that at the beginning, so when the year is, when it's at 0 year, then the book value of the machine is actually 10,000, right? Okay, so after that, the depreciation happened in flat rate by 10%. So which means after 1 year, so it's going to depreciate for 10%. So which means that the depreciation here will be 10,000, then multiplied by the 10%, which is 0.1. So from here, then I'll be able to get 1,000, right? Then after that, how am I going to calculate my new book value? Then it's going to be my initial value, then minus of 1,000. Then after that, I'll be able to get 9,000. So this is the value that I have after 1 year. Okay, so in the second year, depreciation is going to happen again, but then remember it's flat rate. So that's why in this case, it's going to depreciate 10% from the original value as well. So that's why another 1,000. Okay, then the book value here is going to be the previous value, then minus off another 1,000. So which means here you are going to get 8,000 as the book value for the machine. So when you move on to the third one, then you can imagine that it's going to be the same thing because flat rate, so that's why it's going to be depreciating for 1,000 as well. So the next one will be 8,000, then minus off 1,000, then you'll be able to get 7,000 during the third year. Alright, so in this case, you can see that what happened here is that when you try to look at it in a sequence, right, then it actually changes from 10,000, 9,000, 8,000, and 7,000. So by looking at this, you will realize that you have a common difference here, right? So that's why in this case, this is actually an AP that is having a common difference of negative 1,000. So this negative 1,000 is caused by the flat rate depreciation. So if let's say I were to write this in a recursive row, then what I'll be given here is Tn plus 1 will be equal to the current term minus of $1,000. Then after that, I started off with T0 equal to 10,000. Alright, so that's the idea. Of course, the T0 or T1 will be depending on what's the n that we are trying to denote in the question. But in this case, we try to put T0 because it's like the 0 year. So after 1 year, you get this value. After 2 year, you get this value and so. Okay, so that's for the first one. Okay, so now let's look at the second one, reducing balance depreciation. Okay, so same thing. So during the year 0, we are having the book value as 10,000 as well. So we have the same starting point. Okay, so now how much is going to reduce in the first year? So the depreciation here is going to be 10% of 10,000, right? So that's why multiply 0 by 0.1 as well. So you get 10,000. Okay, so how are you going to get this value? You are getting 10,000 and then after that minus of 1,000, right? So that's why from here you get 9,000. Okay, so remember this very clearly. If let's say you didn't continue to your year 2, year 3, right, just by looking at this value, you actually wouldn't able to differentiate whether the depreciation is a flat rate one or is a reducing balance one, because you realize that this is 9,000, this is also 9,000, but the difference will actually happen after the second term. So now you see, for reducing balance, right, is going to be 10% of your previous year. So that's why previous year you left with a book value of 9,000. So how much depreciation is going to happen is going to be 9,000 multiplied 10%. So for the second year, the depreciation only $900. Okay, so which means the book value here will become 9,000 and then multiply 900, which will give you a number of 8100. Then moving forward for the third year, then it's going to be the previous book value, the 10% as well. So 8100 multiply 10%. So from here, then you get 810. So when you move on, then it will be 8100 minus of 810. So for this case, then you are going to get a value of 7290. Okay, then you'll realize that hey, the value here and the value here is actually different, because for flat rate we are talking about 10% of your original value all the while. So every time the decrement is the same. But reducing balance, when you look at the words reducing balance, right, meaning that the book value is going to get reducing and reducing, and the depreciation is going to reduce as well because the book value is lesser, then which means the 10% of the book value will become lesser and lesser also. So in this case, what can you realize here is that you do not have a common difference anymore, because from here to here is 1,000, from here to here is 900, from here to here is 810. Okay, but then you'll realize that you have a common ratio. So let me try to use the other color. You can try to put in your notes here as well. So how are you getting all this value? It's actually multiply 0.9. Okay, because what happened here is that you remove 10%, right? The depreciation happened for 10%, so the value remain for 90%. So that's why it's actually 90% of the previous book value. 8100 is also 90% of the previous book value, and so on for the next one. So which means the other way for us to calculate the book value here is actually by using the previous value multiply 0.9. So in this case, this is an GP. So what is our common ratio here is 0.9. If let's say we try to use a recursive formula to represent it, then it will be Tn plus 1 will be equal to, you use your previous term and then multiply by 0.9. And the same thing, our T0 here will be equal to 10,000. Alright, so that's the idea for reducing balance. So now let's look at the last one here. So we have unit cost. Okay. Alright, so for unit cost, it's not about the timing, it's about how much production that this machine has used to produce. So which means that when we start off, then we have a book value for 10,000 as well. Then from the information here, we know that the machine is going to depreciate for $1,000 when it successfully produced for 2,000 unit for production. Okay, so in this case, which means our term 1 will be after the first 2,000 unit has been produced, then you are going to depreciate for $1,000, right? So now the book value become 9,000. So again, the same thing, if let's say you only stop here, then you'll realize that the value is going to be the same, because just now our T1 is all the way 9,000 as well. Then you move on, you realize that for T2, it will be after you produce another 4,000 units, right? So that's the idea. So another 2,000 now, which means when your production already reached 4,000, then the depreciation here is going to be 2,000, right? So that's why here, the book value here will become 10,000 minus 2,000, which is 8,000. Okay, then move on. If let's say you can, you can try to think of this as well. So what if, let's say now I have reached a production of 5,000, then how much depreciation will happen here? So you can imagine it like this. So for every 2,000 unit, right, then you have, I mean, of course, in this case, I'm not talking about 0, 1, 2 because this is like not consistent already, okay? But then, okay, maybe let me try to do like this. So if let's say you have produced like 5,000 units, right, then what is going to happen is going to be 1,000, 1,000, and then 500, right? So that's why the depreciation will be 2,500. Then at the end, you're left with 7,500. So that's the idea. But here we try to make it consistent. So which means if let's say you already produced for 6,000, then now the depreciation will be 3 times of this. So which means 3,000. So the book value here will become 7,000. Alright, so that's the idea. I hope that you can understand it. So for here, you can see that it's going to be like an AP as well, because you can see the common difference here. But then I wouldn't really agree to actually solve it by using a recursive rule, because at times you will have this case, which means that you are producing like 5,000 rather than going like 2,000, 4,000, 6,000, 8,000, and so on. So you need to understand how to calculate it by using a common sense rather than memorizing it, whether it's an AP or an GP. Okay, but the idea here is an GP because of eventually everything will be lies on a straight line graph, because you have your unit of production here. Then after that, continue with your book value here, right? So at the end, what are you going to get is if you produce like for 2,000, okay, this is the original value. After you produce 2,000, then it will drop for 10,000. You will drop for 1,000. Then after you produce like for 4,000, when it reaches a production for 4,000, then it's going to reduce another 1,000 and so on. So that's why it will give you a linear graph as well. Okay, so that's the idea. I hope that by using this simple example, you are able to differentiate all this. So there are actually no formula that can help you to do depreciation. So everything that you are doing, right, is actually just growth and decay in sequence. So that's why try to use your common sense and your prior knowledge that you have in growth and decay to help you to solve all these questions. Alright, so that's the end for this video. So yeah, if let's say you got any question, feel free to just ask me, and thanks.